Welcome everyone to this week Community Live. I'm Lakshay, Community Operations Specialist at Zyte, and today we will be learning something different, like how you can enhance your AI agents using the web data that we will get from Scrapy and Zyte API. And for the practical understanding, we will be using a finance AI agent as an example. So I will pull up my screen so you can see.
Oh, yeah. So, for our today practical understanding, we will be using a finance AI agent as our example. Actually, there is a story. So lately, I have been diving into the finance to learn about some good investment stocks. But going through daily news and articles and other updates is quite hectic and manual. So uh, and like it's an era of AI agents, and it is going to be really tough, doing this manual task on day-to-day basis. So I just I thought, what if we have a AI agent that could do our work? So, but the thing was the AI agents that were available, they had sort of, limited data access. The LLMs that were there, they have the knowledge cutoff. So, and for the finance analysis, we need real-time data. This is not a finance session at first of all, I'm just trying to create the base like what we are going to focus on today. So uh, the idea behind building this agent was like, what if I could feed the same data I have been reading on daily basis from the finance side and directly into this agent, and that way it could give me summaries, answers, or even questions like the answers to my questions, or even so it could take actions based on the summaries that we get from the transcripts or the press releases. But there is a catch here. Getting summaries and answers is one thing in the AI, and taking direct actions based on those summaries is different thing. If the agent is taking direct actions based on the insights it has provided us, that is something different. So to understand that better, we need to understand one thing, the difference between the AI agents and the agentic AI. So take AI agents as the software system designed to automate specific well-defined tasks, like which have the predefined rules. It might be a chatbot, it might be a small sorting tool. If we talk about the agentic AI on the other hand, it has a broader scope of autonomy, right? It can take decision by itself. So what we have today is an AI agent, but it can be converted to an agentic AI because both have the same foundational base. The key building is the custom data pipeline which will power the our AI agent, right? And that's exactly what we are going to cover today. So to do that, we will combine the web scraping with the AI agent for that purpose. So if I take this architecture.
Purpose, and we will be using few tools. First, we will use the Scrapy for structured data extraction, and we will use Zyte API as the targeted website is quite complex to handle that. You can do it also with simple Python, but I would say why we use Scrapy and Zyte API together. Also, I remember a past discussion in the community, where someone said, "Why do we even need a scraping API when I can just write scrapers myself or rotate proxies and get the data?" And that's where you can definitely do it. But I think walking through this project, you will know why tools like Zyte API matter. Like when you're building something at scale, it's not just about can you do it, it's about comparing the time you invest with the cost. At some point, time becomes very more valuable, and your focus should shift to optimizing and actually using the data, not constantly working about how to fetch it. So that's the part a tool like the Zyte API takes care for you. So you will know better as we move ahead.
We will combine this custom data with the two famous libraries like DuckDuckGo and Finance Search Client for the latest data from the web. And then for building this multi AI agent, like these three are in the box, which is a multi AI agent. And we will use the Agno framework, also called as PyData. And for the LLM side, I've used Grok. You can refer to any local LM or Llama or anything else. But yeah, the model I will be using the Llama 3.3. So I think it's 3.2 or 3.3. Yeah. So let's begin with this architecture only. So as you can see, we have the three main data sources. These two, I would say these two are the general APIs, so we don't need to focus. The main data pipeline is this one where we need to focus. So first one is our Scrapy Spider. uh, I'll also show you the code side by first. Yeah. So we have mains four main spiders and one base spider. Like you can consider this as the base spider. So uh, the base spider has certain general functions which are used by all these four other spiders. So that's why the base spider is created. In the first step, when we use these spiders to fetch data, we don't fetch the content, but we fetch the URLs of those content, right? I will tell you why we do that. Except the comment. For the comments, we definitely don't get the comments data at the first is. So the thing is, if we don't get the content because lots of the content on the side is quite irrelevant to us, right? We don't need to read every single news, which might not be good for us. So that's why we just get the URLs and later we run some trend analysis and then we create our own trending URL list and then we do the scraping of that content specifically. That saves our cost and we are using LLM to provide us the summaries, the answers to our questions. And LLMs comes with a cost, right? They're the cost per token. So the data you're gonna feed it should be limited, should be the relevant data you're feeding it, right? So that's why we just don't get the complete content from the website, and it's so not ethical, right? We need to don't send multiple requests on the website. We should be keep the limited request. So yeah, so we have these four spiders. I will walk you through it. We won't deep dive into the basics of it, right? If you want to learn about how to use the Scrapy and Zyte API together, we have a complete Zyte API lab series, the Nia and John did it, so you can find it on YouTube. I will drop that link to it after this session, so you can watch it out, how you can set the escapers. But yeah, so our base spider, we have few main functions, like we clean the URL. So like we basically do the normalization and deduplication here. So the thing is, the URLs that we scrape, as I said, they come up with UTM parameters, right? They're of no use. So we normalize all the URLs to so they are standardized. And then if we are scraping URLs from different sections like transcript, the press releases, as you the transcript, press release, and news. Sometimes the press release could be a news as well, right? So that would make repetitive URLs in our data sources. We don't need that. So we just remove that URL with it. So and then on site you will find the article will have a not exact date, but yesterday today written like in a variable, right? So we need a proper date to compare. Like I said, we will run a trend analysis over it, right? We will assign certain scores that okay, this article has a great score, so we need to keep it at high priority and use it more during the analysis of our answers. So we use the convert system and we see when we convert our yesterday today to our proper dates. uh, yeah, and then we have our comments. Similarly, we do the comments. We send the request via Zyte API. Just you can configure the Zyte API with here. Just set the Zyte API and respond to true, and set your Zyte API key. Always set it into your global like the environment, not directly hard coded into the settings of Spy. So yeah, with that so yeah, every request we are sending from our this command spider is passing to the Zyte API. We are, there is a proper maximum, like the site as in reference has a scroll count, right? So we have set it to 15. You can do it more if you have more time. I wanted to keep the bullet small, so that's why it is set to 15. And uh, yeah, and then we, so yeah. See, I told you like we will do a trend analysis on uh, the the URLs that we got, and then we sort them based on the priority. So that we do with the help of the IDs. So so if you see here, like I'm trying to connect these comments to these three articles, right? So we need certain comparative parameters that via which we can compare that. Okay, this comment related to this news, this comment related to this press release, right? So for that, whenever we scrape this URL, we use the hash values. Those hash values are created out of those URLs only that we have, and then those hash values are compared with each other once we do this. But in the comments, we have the function I told you, for which we do the comparative comparison, that is set up into the like here in the base spider. Yeah, here the create ID, right? But this comment one is the different one. What it does is it, for example, if I'm scraping the comments, but uh, if any comment is relates to single article, right? For that the ID should be same. So that's why we have the three IDs. One is for the comment and one is for the in comment itself, which relates to article, and which comes from here because we are importing the base class, like the parent class is the base spider, so it comes from here directly. One good thing is here is we are not directly implementing the base spider functions in our spiders, right? We are using pipelines for that. So I think that's what make the Scrapy really cool, rather than using this simple Python, right? So see, we know whenever we're in the spider, the pipelines are going to run along the way, right? So we import our base spider here. For example, let's consider one function. So for example, if there is a create ID, right? Uh, when I run the comment or a news, right, it will run up, right? It will import the this like a parent class, and which will also bring up the create ID function into it. And if I will show you the pipelines, we have the normalization, and I think we have the ID somewhere. Yeah, see, like we just create ID here. So uh, that's how the chain has been built between different between the Scrapy. So this is done for all of these, right? For the comments, for the news, for the press release, for the transcripts, and yeah, we were here in the comments. So yeah, then we got the browser HTML. We just parse the content. We create the ID, and that's how it is done. Yeah, these are just the parsing we've done here, and similarly into the news. So yeah, for the news, yeah, just we have to set the meta pyramids again, and we've done the parsing again. So we've done the simulating in the transcript in the press release, and some common function has been specified into the base spider. So, but like if I show you some data, okay, so it should be like this. So see, we have the complete data. I'm not going to run the script right now. It is going to definitely take a lot of time. So, but we have all the news, we have all the transcripts, and it is completely publical data, right? No logins, nothing. Just always try to keep your project ethical. So back to the architecture. Yeah. So once you got all of this, the URLs, the comments, and then we try to link these comments together to these, like the news, the press release, and the transcript. So for that, we use our trend analysis function, the this one. So what this does is, uh, like first it uses the ID, like the ID. So there are, I told you there are three IDs. One is for the comments that we are not going to discuss now, but there is one ID that relay that this news, press release, and all of this ads. So let's call them articles, right? Because they are overall the articles only. So there is the article ID that relates to this, and there is the parent ID, like the comment ID that we have, right? Not the comment ID, but the parent ID. Let's call it the parent ID, which is for the article in the comments. So they will be same, right? Because we have scraped the URL and we know the comment links to this URL, right? Which will be under the article. We know both of them. We'll link them together, right? Now in the second step, we done the now we do this called the we put some score in each of the article. So if I when you run this up, I think that will give you the better idea. So go to analysis. So yeah, see, we have got these articles. See, this with the score of 33, with the 30, with the 18. Well, like how I've calculated the score. So I've considered five parameters. So if we talk about the first, we consider the comments. So for example, if any article has a single comment, it will give it 3 points. Maximum I've capped it to 30 points. Like we can only consider 10 comments each article, because if it has a 10 articles, it is already a trending article. We don't need to uh, uh, increase its points, and also need to focus on other articles. So we need to keep some benchmark. Then there is a mention score. So if the article has been mentioned in the comments a lot of time, right? If it is a discussion under another article, and we are uh, like talking about this article in another article, so that gives the 2 points. Then there is the data score, like how much data is repeated, so we give that point between the 0 to 3. Then there is a date score as well, like if it is a recent article, we give it a point. If it is a 1 week article, we give 2 points. If it is a really a month article, we will 1. If it's more, then we'll give 0 point. Then what's the source of this article? Then based on that, it is a press release, a transcript. If it's an official press release, that gives it the more points because it's the official statement, right? And then there is the engagement score. Like in the engagement score, I've kept the length of the articles. If I show you somewhere, uh, Yeah, see, this is the weight of the article, and I think this is yeah, I think this is the one. Yeah, comment count published. Yeah, if it is all, we assign these points. So yeah, so these are the five parameters that we consider. Based on this, we create a yeah. Based on this, we create article summaries. So if you go here, once we get this trend analysis, no, sorry, no, we not create this. Sorry, there's no so files. So we actually create yeah. Once we have got this list, like this list, right? We do the scraping again, right? We have a separate file for that. If I take you to the so files, yeah. So we have the process article file. So I told you like you can do this project with the Python as well, right? So I wanted to give the taste of both. So see, when I use the Scrapy, I didn't need to write all of this again, right? I use a combo thing, the spider, but I need to guys this anonymization utility again, which I used in the pipeline itself, right? I showed you it. See, we already have it here, but I need to write it again. So that's how Scrapy really helps you in the things of just that's how Scrapy and Zyte API go hand in hand. That's what I say. So yeah, but let's consider this. So to process these articles, wait, let me also walk you through this. So yeah, once we have this trending list, which we go it based on some point system, comparing these IDs, we fed this list to the processing folder, right? We can call it a folder. So in this we do two tasks. One is the scraping. We scrape those top articles. Like we can set. I have set a range of 10 articles, like top 10 articles I will be scraping. See, there was, I think, the results. If I show you the results again, for example, if I show the news, sorry, not this, the PS1 file. If I show you this, you will see, we have a bunch of data, right? And out of this, we, first did this trend analysis. It removed some of the stuff which is not important. Trend analysis also, I set it to 50 to only show us the 50 results. If you count this will come to 50, right? But out of this, when we process these articles, like, we'll be setting the processing tab, we'll scraping them. I will set it to 10, and I can even, set to, so yeah, so our article summaries, once we process it, it will come like this. Like these are 10. So and like if you compare this with this, I think it will be the same. I see that this article title was not fetched, but if you see this, and we said to develop a AI chip, right? We just skip this one only if you compare these two things here. So that's how we save our cost, we optimize it. We are not going to fed unrelevant stuff to the block, like when we fed the final data. But yeah, so yeah, sorry, yeah. So in the processing tab, you will see this. I will first do the scraping, right? Also in scraping, we did it in the batches. We didn't, just send out multiple requests to a site, right? We did it in the batches. The batch was of 2. So in every batch, I send the 4 requests, right? So we keep the wait time so that we don't overwhelm the server. And also, if I show the skipping part of it, so the approach I followed for this one was like, I used a fallback method, right? First, we tried to get our content with the browser HTML, then we used HTTP response because the site that we are trying to get, I can't name it definitely, but was really hard, right? The content that we have on it was loading in the partial stages, right? If you send one request, it will get you the complete content. In the second request, it will get you the partial content. So that's why it's at a fallback. If we can't get the content properly, it gives a second try with the HTTP response. So that's how I solved that problem. For this, I specifically use the article and set it to true, and that how the data was fetched up. So you can see that this is the browser HTML function, then you have this HTTP response one. So that's how we send the request for scraping those top 10 articles. Now then we ran this article process. So as I said, there were two processes involved in this processing. One was to get the complete this data, and then second time we send this data to the Grok, uh, uh, where we summarize each of the articles that we have scraped. The reason being, I'm using a free trial at first order. So on the free trial, we have a certain limits. So once if I didn't process the data here, summarized it up, and I fed it this data, and this data combined to an agent, and then run it through the llama model, it would have been really tough to uh, get the proper insights, right? So in early stages, only we summarize it up. Yeah, it will get lost of some data, but you get the idea. You can do it, right? You can use some paid API, or, paid OpenAI or API or anything, and you can do it much better, right? So it is just to give you an idea. You can build this custom data pipeline, right? And how the approach you can follow, how you can save the cost. So yeah, we build up this summaries, and so yeah, these are the summaries that I showed you here before I tried. These are the complete summaries. The summary content is there, right? So yeah, once we do that, we just we just fed this complete data from three sources, and you will know how we do that. So if I walk to the agents folder, we see the finance agent, and under it, find we have directly imported our Y finance tool directory tools from Agno only. And first we build our. Okay, let me do this like this. Yeah, so we have three classes, two classes and one function here. So uh, first one is the main one, like this is the, I would say, the complete thing we have done, from scraping out four spiders to building those relations between IDs, and then scraping it again, the content, and then summarizing it up. So after that, we need to build a toolkit to use that data as well, right? So for that, we created this class that is to initialize it, and it will get those summaries from the, yeah, also be like we're targeting the single stock, right? Nvidia, nothing else. So we'll get this data, and we will just process it for the later part, and then we have this some uh, other functions, yeah, just logs that we have, and yeah, we just append this data later use. Now if I work with this, so this is the basic agentic setup for the biofinance integrator. You can I think if you are dealing with this, you already have the idea, but yeah, we just, it is the model to use the Olama, and I used yeah, it was Llama 3.2, and this is the version I have been using. And then uh, yeah, so see, when we are gonna run the final results, we have the three options to run. Either we can run the output combining all three data, right, from the DuckDuckGo by Finance and the custom data pipeline, or either we can run with this just using the DuckDuckGo and by Finance, and we can run it with the custom data as well, right? Then I did this for the debugging purpose, like how much relevant data I was able to fetch, but it's still lots of optimization. Yeah, so see, if the data model is all, we will use a custom data pipeline, we use the Y-Finance, we use the DuckDuckGo together, right? But if it is no custom data involved, we use this just the two general APIs, the DuckDuckGo and the Y-Finance. If it's the custom data only, we will use the custom data tool function as defined up like under this. So yeah, thanks, Keko. Uh, so yeah, after that, we just use some basic instructions to how to combine this into three different scenarios. And but this is not the actual prompt that the LLM is going to use. So this function helps to run another file, which is the main file, which controls everything. Like this is the file where we set up everything. So the prompts we need to send to Grok for the final output, or uh, uh, like yeah, I follow this basic structure, like the key developments, financial analysis, investment outlook. I'd say this really needs lots of optimization. I need to try it with different prompts, but yeah, as I said, it was just to give you an idea how you can build it up. So let's just try it out, and let's see how it works. As I said, we can run this model into three ways, with the combining all three data sources with the two sources, the general APIs, or using only the custom data. Let's do it first with the custom data, right? If I say it like I think the custom data only, I think that will work. It. Oh no, sorry, I'm in the wrong directory. I think that will work. My resources are completely consumed. I'm streaming it up, recording it together. So uh, okay, cool. It's working now. So the request has been sent. So see, we got all the four insights. Like these, I would say these are four generals, but the main focus should be on this committee insights. Like we got the summary. We got the user was talking about. This is not a real user definitely, but the content is real. So like how the highlights for Nvidia market cap, expressing confusion about frustration about the personal financial. As I told you, I was spending some time to learn about some finances. That I'm reading all of this article together, right? Going through each article and then coming up with an insight, right? And if I get it completely here. We can also run it directly. As I said, we can run it in three different ways. You'll say it, uh, the content with here only, but the logic, you get the idea how you can plug in the custom data pipeline. So as I also told you, this is a AI agent, not an agentic AI, but you can convert it to it. How you can convert it? It's quite simple. You need to spend some time. You can nowadays, like lots of I would say the investment firm or the stockbrokers provide the MCP, uh, like the model context protocol as well, right? And they can you can connect that to this, right? The AI model can take decision on investments on behalf of you. Definitely don't give it a complete access, right? Just set a manual step that it will tell you can take this step. Otherwise, it's gonna make it really uh, I don't know, the bad investment or something. So just definitely set the manual step, but you can the flow right now, and you can definitely build out something really a good agentic AI tool for the finance, or by the finance, you now know how you can connect those data pipelines. So you can build something around e-commerce, something around real estate. You can do anything, right? So uh, yeah, I think we covered lots of things. Let me also show you the output. Otherwise, you like it didn't work. So see that we ran with the like combining all of the things. See, running all in data model, and we just fed all of the data together, and we have the investment outlook, we got the current stock price, we got the recommendation as well. So I will set the confidence level. So it was just sort of debugging, like uh, if I ran it with the custom data, how the confidence come. It's not optimized, as I said. I think it is not gonna. Yeah, we see. I think, yeah, we didn't get it here. Hmm. So that's how sometimes LLM doesn't get you the correct data, but yeah, it's okay. We get the confidence of it, and yeah, the same thing we get it here as well. Like my impressive, but I'm concerned about the company's valuation, potential risk, market, and everything. So yeah, I think that's how you can build it, and you better get the idea about it.